Hi, good evening, everyone, and welcome to the third and final day of the workshop on topic data visualization using Matplotlib and Seaborn. So, till yesterday, we have covered basically all the Matplotlib basics, and then yesterday I introduced Seaborn to all of you, and today we'll culminate this workshop. So, we have got some constraints as it is the final day, so the workshop might extend beyond its time. However, we have got another workshop which is running in parallel, the GitHub workshop, which starts from 7 p.m. So I will try to finish this workshop by 7 p.m. So with that introduction, I want to say another thing that today my pace might be slightly, faster. So please try to grasp the points. However, anywhere you feel stuck, please pipe up and we'll stop and we'll cover that concept. So with that introduction, let me share my screen and let's start. Just let me know when my screen is visible to you. Just anyone, if somebody can give me a hands up. Thanks. Okay, Shristi, thank you. Thank you so much. Okay, let's go. Okay, so today what I will follow the same like I had covered for the Matplotlib. I will cover first all the plots. What are the purposes of those plots? What are the real world uses? And while covering those plots, I will be covering certain important aspects of marking those plots, increasing the sizes, and all that. So Seaborn has got different plots. So first, I will cover distribution plots. They are of type plot, hist plot, KDE plot, ECDF plot, and rug plot. And Seaborn has also got a wrapper which is disk plot. So just by using disk plot, you can use all these plots by passing parameter kind and in give hist, KD, ECDF or rug and you can use. So we will see them one by one. The second type of plots are the relationship plots. So scatter plot is for relationship between two variables, line plot, regression rag plot, LM plot we had seen yesterday. And for that, the wrapper is rel plot. REL stands for relation, rel plot, and then passing kind param, you can have these plots. Categorical plots, we have got bar plot, count plot, box plot, violin plot, strip plot, and swarm plot. And for that, the wrapper is cat plot. For matrix and multivariate, we have got heat map, pair plot, and cluster map. For them, there is no wrapper, they are standalone. Okay, so what are the wrapper APIs? So basically, the wrapper APIs, they simplify everything. So for example, with disk plot, you can plot hist plot, KD plot, ECDF plot, and rug plot. With rel plot, you can plot scatter plot and line plot. With cat plot, you can plot bar plot, count plot, box plot, violin plot, strip plot, and swarm plot. So I will cover the difference. What is the difference? For example, you are using this hist plot and disk plot. So hist plot, basically, it is like you are plotting on an X that you first are making a figure and X. Whereas when you use a wrapper, it is at the figure level. So as we see the examples, this difference will be evident to all of you. So this plot, like we pass kind is equal to hist for hist plot, kind is equal to KD for KD plot, ECDF for the ECDF plot. In the rel plot, we pass kind is equal to scatter for a scatter plot and line for line plot. And for cat plot, these are various kinds: bar, count, box, violin, step, and swarm. So let's start with this introduction of all these kind of plots and the wrapper. So wrapper makes life much easy. So I will cover these plots one by one with the same theme by which I had covered Matplotlib. I will give you the nickname of these plots, basically to remember. Remember, these are the nicknames given by me. So they are not coming from any authentic source. It just makes you makes easier to remember the theme behind this plot. So let's start. So first we import the standard libraries. for that. And for today, we will be using the real world data from the Titanic data set. So from Seaborn, we will load this data set and let's see how the data set looks like. So data set has got a target label survived, then the passenger class, sex, age, sibling support, parental, fare, embark, class, who, adult male, DAC, embark down, alive, and alone. So these are the columns. So let's jump to his plot first. So we will see the his plot first, and then we will see the same with the wrapper. Okay. So his plot nickname is how many. That how many things are there. So it is a count plot. We are counting for that category. And what question does it answer? It is answering how many passengers fall into each age range. So you see here, so for this, I'm plotting a figure, plt.figure. I'm passing the argument fixed size is 43. And now I pass data is Titanic, which just now I downloaded. I'm passing the X, so I want to plot the age count. Bins, I'm passing 20. I'm giving hue. So yesterday we had discussed about hue. So hue, I'm passing sex. KD, I'm passing true to see this line. And let's see how does it look like. Okay. So in 4 by 3 inches figure, I have got this count, and you can see, I can see the counts for males and females separately. So when you see the bins, I can see the numbers that, for example, in this number, these many females are there and these many males are there. Similarly, in this bin, around 25, you can see these are the numbers of males and these are the number of females. So this is basically giving you a count. So what is the insight which we gain from this plot? We can see that most of the passengers are in this bracket, 20 to 40. So this is the insight which we gain from this. Now, if we want to use with a wrapper, so we plot the figure, fixed size 43, and then we plot. This is the disk plot, which is the wrapper in which we can pass kind is equal to data is this, X is equal to age. In this plot, your default is hist. So here I have not passed. I can write also here, default is hist. And here I am passing KD is equal to true. Now here I would like to demonstrate an important thing to all of you, that though here also I had passed fixed size 43, and here also I have passed fixed size 43, but you see here the size is not 43. Why? Because this wrapper which is there, this is a wrapper. Okay, so I will just write wrapper is at a figure level, so it automatically decides its size and it overrides this plot figure size. Now we will see how to change the size if we are using a wrapper. Okay, so I have explained it here that SNS.hisPlot is an axis level function. It draws into a specific Matplotlib axis. Since we called figure size 43, his plot simply fills the empty box we created. Whereas SNS.displot, it is a figure level function because it is a wrapper. It is a wrapper around the axis level function. And when we call displot, it ignores any existing PLT.
Hello.
Yes.
Chapandi.
Who's this?
Ah,
Yeah,
okay.
who was that? Please mute your mics. Let me finish, and if there is any confusion, I will repeat it. Am I audible, Umapati ji?
Yes, sir. You are audible, sir.
Okay.
Please.
Okay. So what I was covering, that this is a plot which is at the axis level. It takes this size. When I use a wrapper, so this plot is a wrapper, it disregards all other sizes and it will take its size automatically. However, if I want to pass a size is in a wrapper, for example, then we pass a wrapper size like this. SNS.dispplot, we pass the data, we pass the X, wins is equal to 20. I will request everyone to mute their mics, please. I hope all of us, we are mature enough for that. We pass KD is equal to true, and you see these are the two important different parameters which we pass with a wrapper, and it is applicable to all the wrappers. So we have got three wrappers. We have got a wrapper called displot, then we have got a wrapper called cat plot, and then third wrapper is called a rel plot. So if you want to control the size, you pass the height and you pass the aspect. So width will take the aspect 3 into 1.33, which comes approximately around 4. Okay, so that is the difference between a wrapper and a basic plot. Now we see the second type of plot. Second plot is KDE plot. KDE plot is how likely. So it will give you the probability. So yesterday somebody had asked me this question, that here it is giving count and here it is giving probability. So this is the difference, that when you have the hist plot, it is giving you the count, and in the KDE plot, it gives you the probability. So let's see the first KDE plot here. So KDE plot, again, I'm passing the figure and axis using Matplotlib. Then I'm passing, so they here see, I have built axis, there are 1 row and 2 columns. So if I want to plot this KDE plot on x0, so this is the parameter I have to pass. X is equal to axis 0. Data is catenate. X is age. Fill is equal to true, so to fill the bar. In the second example, I will do the fill is equal to false. Where I want to plot this? In axis 0. And I'm giving label is equal to age density. And here, I will cover how to control the legend. So if you are using Matplotlib, for example, here, so we had seen in the Matplotlib, we give something like, we give the name of the axis, then we pass legend. So we can pass like upper left, upper right, lower left, lower right. So the legend will come inside the axis at those positions. I have set the title. For the second plot, I am passing x is equal to axis 1. I am filling false. And here I am using the Seaborn function of moving a legend. So in Seaborn, there is a function called move legend. In the move legend, it is mandatory to give lock. Lock is equal to upper right. The title I have given. So here I am demonstrating two things. One is using the legend by Matplotlib, and second moving the legend by Seaborn. Let's see how do it look like. So see here, it has come here because for the legend upper left I had given, so it has come upper left. Here I have used SNS move legend. Location is upper right. It has come upper right. Now I want to change the location of these legends. So I can do by both ways. I can use Matplotlib method also. I can use Seaborn method also. So let's see it one by one, how we will do. This is the inside where we can draw from this KD plot. It is giving the probability. Here is the age. So in both, here I have given the hue, male and female. So for both, we can come to know that the younger adults are most common. Now, like I mentioned, how to change the box, that legend. So for Matplotlib, I can use axis 0, legend box, B box to anchor. I'm giving minus 0.1 to 1. So remember 0, 0, it is like a graph. 0, 0, you can see XY graph. 0, 0 is bottom left. 0, 1 is left upper. 1, 0 is bottom right. 1, 1 is upper right. So by passing this position minus 0.1, I will try to shift the legend on the left on the upper side. If I want to do by using the SNS move legend, so I will give lock. This is mandatory. Without this giving lock, it will throw an error. and I use the same function for Matplotlib, that is BB box to anchor. I'm giving 1 1, so it will come on upper right. Like I mentioned, that with the plots I will be covering these different things so that we don't have to explore them separately.
BB box is for the matplot, no?
Yes, but it can be used in the SNS move legend also. When you want
In
to
the
SNS,
okay, in SSN also both can be used.
yes, yes. But when you are using inside the SNS, you have to give this lock mandatorily. Whereas in for Matplotlib, it is not mandatory.
Okay.
Okay. So you see here I passed minus 0.11. So it has come on the left side outside the axis. Here it has come 1 1. So it is inside here 1 1. Now, yesterday somebody had asked me that all these legends, are they inside the figure or outside the figure? They are inside the figure. The fig size remains the same. As you change the positions, like if I do the position of this 1.5, if I do, then what it will do, it will allot this size to the legend and see your size of your distribution or your plot has changed. So this is how for you have to do hit and trial to find the optimal place for this.
Even the
So
axis dimensions are changing.
which one?
So the chart axis dimension also is changing, sir.
Chart's dimension will not change because by gender, what we are plotting the age. So age cannot change. The age will remain the same. Only your shape of the figure, because it is trying to adjust in the same fig size, and it is allotting a new space to the legend. That's why if I don't give anything here, for example, if I give 1 1, see, presently you are seeing it is narrow valve shape which is there. If I give 1 1, it comes inside. You see, axis has changed slightly, but it is covering the same edge, but it has slightly become broader. Okay. Now for this, the wrapper is sns.displot, and we pass the same we are plotting. We are passing kind is equal to KDE because this is a KDE plot. And here I want to define the height also. So I have defined height is equal to 4 and width is 5, around 5.35. And I'm using SNS move legend. I'm giving the B box to anchor 1 1, which means top right.
Which one is 5.35? Is 1.33?
The height I have given, and your width is defined by the aspect. When you give the aspect, your width will become 4 into 1.33. Is that clear? Okay.
Yeah. Okay, sir.
Okay. So here we have seen the wrapper and how to give the size in a wrapper, and using the SNS command, how to move the legend. So all these 3 things we have seen in this. Let's come to the next plot, which is the ECDF plot. That is the empirical CDF plot, which is the nickname is what percent basically. So it will give you a cumulative distribution of age. So you can gain an insight, for example, what percent of passengers are below 30. So if we plot this basic plot by using sns.ecdf plot, so I am plotting this Titanic x is equal to age.
Once, please repeat, sir. Voice was breaking. Please repeat last line.
It gives the cumulative distribution of age. It gives an insight about what percentage of passengers are below age 30. Okay, depending on the column which you are visualizing.
Okay.
Okay, now here I will plot simple Titanic x is equal to age, and then I will plot with class. So with the class, that cumulative distribution will come. So let's see how this basic plot will look like. So see, with this age, the cumulative has come. So you can see if you draw 50, so you know around 80% of the people, they were below age of 50. If you see 30 30 is coming around 40%. So 40% of the people, they were below age of 30. If you want to see class wise, so you can see class wise also. So these are the colors for different classes. For different classes, you can come to know what percentage of the people that age they were in that class. This is the power of this. Now for this wrapper, you again use disk plot and you pass kind is equal to ECDF. And I'm plotting with hue is equal to sex, the same one which I had plotted, and it will give the same. So here
What
I
do
have
you
given
explain for the ECDF, cumulative distribution?
it is, yes, cumulative distribution. So it is giving cumulative probability.
ECDF full from? ECDF.
Empirical cumulative distribution.
Okay, fine.
Okay, it is
Okay.
cumulative probability distribution. It is accumulating probability. And you can see now I have used hue is gender. So it is giving with the gender. So here you can come to know what probability of that age was there gender wise. Okay, till now this thing is clear.
Okay, sir.
Okay. The last plot in the distribution is called rug plot, which we had seen yesterday also. In the rug plot, the nickname I will give every single point. So every single point is plotted. And what question does it answer? That where exactly are individual passengers' ages located? So it can show data density and it also can give the outliers directly. So let's see this rug plot. The rug plot is sns.rugplot. I will plot age and then I will plot age with the hue sex. So generally the rug plot is never plotted individually. It is always plotted with either your bar or with your line. So to see along with that what is the distribution. So you see here, this is the rug plot for age. So immediately you know that there is an outlier. There is a guy who was 80 years old. We have got few infants also, but majority of the population is from 20 to 40. You can come to know. And same thing you can know here also, where I have used gender. So you see after age of around 65, all were males. There was no female. Okay. This gives you that idea. So till now we saw his plot, we saw KD plot, we saw this rug plot, and the wrapper for all of them was this plot. Any question, any doubt till now in this? And while covering this, we also understood how to change the size when we are using a wrapper. We also understood how to move the legend using Matplotlib if I'm using axis. And if I'm using a wrapper, then I can use sns.moveLegend, in which I have to give lock mandatorily, and then I can use the BB box command. Any question, anyone?
The wrapper you are talking about the I joined 2 minutes late, so wrapper kind of thing.
Wrapper. So I will request you please have a read here, okay? And later on you can ask me a question. You can send me a query on GSpace. Yeah.
Okay, fine. Okay.
Yeah. Like I mentioned, today is the last day. I will try to keep pace slightly faster so that I can cover all the topics. I have got some advanced topics also. Okay. Okay.
Okay.
Now we go to the next plot, which is called the relation plot category. So I will cover the basic plots also, how we can plot them individually, and then how can we plot them using the wrapper. The wrapper is rel plot. We can use sns.rel plot, and inside that we can pass command kind is equal to scatter or kind is equal to line. So first we see scatter plot. Already we have seen in Matplotlib. It is a relationship finder. And for example, here, how does the age is affecting fair? So if we use a normal plot, then the command is sns.scatterplot. We give x and y because we are trying to find the relation between x and y. We also can use this with a hue. So I can pass hue is equal to sex. Now here, remember, in the relation plot, there is an extra argument which is called style. I can pass another column as a style. For example, here I will pass survived. So it can give us a relation between age and fare, gender wise, and whether they survived or not. So let's see all these three plots. Okay. So the first plot is age versus fare. So you see there is no relation between age and fare. Okay, there is no linear relation or anything. But you can come to know, for example, there is a fare around 500. We don't know who are they, but we know their age group, that they are between 30 and 40. Now, if we want to visualize this, now I have given hue is equal to gender. Now, by hue is equal to gender, immediately I know that these were two males who were having this fare, 500. Here I can come to know that from 70 to 80, all these people, they were having fare which was below 100. So this is the power of the visualization. Okay. And third, I pass style. So here I can come to know whether these people survived or not survived. So see here, these two people, they survived because it is one. One is for survival. This 80-year-old person also, he survived. But these people who were there from 70 to 75, around 6 of them, they have not survived. So this is the power. So here we are visualizing age, fare. We have got a relation. We can see from this graph that there is no relation. Then we can see between male and female. And then we can see between survived also. So this style argument which is there, it is used only in relational plots. Okay, now see for the wrapper, like I covered, we use the wrapper rel plot. We pass the data, we pass x and y, and we pass this kind is equal to scatter. Okay, and I'm using hue survived. Okay, so I have got the similar kind of graph where I have got male and hue is survived only, age and fare or survived or not. So here I can see they have survived, and this 80, this person also has survived. The
So
next,
for scatter plot, the wrapper is not disk plot, right? So the wrapper is different.
yes.
Your voice is
So
breaking.
yes. So please try to keep pace with me. I covered 4 first plots, which were distribution plots. For them, the wrapper was disk plot. Now we are covering relational plots. For them, the wrapper is rel plot. Is it clear?
Yes, and the style column should be a boolean. Only then.
Yes. Style is a boolean, then only. If you got, for example, 3 also, it will work. Okay.
Yes.
Even okay, for hue also, you cannot have hue more than 10, otherwise your graph will clutter up. Okay. Okay. Now let's go to, so we have seen this relation plot wrapper. Now we go to the next relational plot, which is a line plot. And this we had seen in the Matplotlib. The nickname for this is trend over time, that how the things are trending. So for this, if I want to use Titanic column, so I will check, for example, I will see a relation between passenger class and the fare, that how the fare is there amongst the passenger class. And I will also use, here I will just see passenger class at fare. But if I have to see the mean, that how the fare is there, so in the SNS.line plot, I have to pass this argument estimator is equal to mean. Here this CI is equal to none, like yesterday we had seen. This is the confidence interval. So the first plot in this, the confidence interval will come. Here it will plot mean of fare without confidence interval. And in the third plot, I will plot it with hue is equal to sex, and I will give a style also embark, and I'm giving confidence interval is equal to none. So let's see how they will look like. Okay, so let's see the first one, first plot. This is passenger class. So we know that there are 3 passenger classes, 1, 2, and 3. These are the mean fares. So here the mean fair is around 82. This is the confidence interval that it ranged from this place to this place. For 2, this is the confidence interval. For 3, this is the confidence interval. When I plot it without confidence interval, so I get the correct things. So there is no confidence interval. And if I pass with hue is equal to sex and style is embarked, so hue it is giving for me for male and female. So blue line is for male. And then it is giving embarked. Okay? So from 3 places the passengers had embarked. So this is giving me dotted line, solid line, dotted line, and more dotted line. So I can see for male 1, 2. So it is for S and C. So it gives me an indication indirectly that there was no male passenger who embarked from Q. So this is one hidden insight I have obtained from this graph. For female, I have got from all 3. It is in orange color. So I know their fares also. So solid line is for S. S fare is less, whereas the C fare is more for females. So this is the insights which you can derive from this graph. So again, to repeat, in the relational plots, I can use style also, a column with category kind of data, and I can plot that. Now for this, if I use now wrapper, I will use rel plot. I will pass data X and Y. I'm passing kind is equal to line. This is the argument for the line plot. I'm passing hue is equal to sex, style is embarked, CI is none, and it will give me the same plot. Okay, any question now here till now? So we have covered basically 2 types of plots okay, till now, 2 groups of families. Again, I will just revise for you that what are those 2 types. So somebody has come 2 minutes late, so for his benefit. So these are the basic plots in the Seaborn. So we can group them in distribution plots. So in the distribution, we have got HIST plot, KD plot, ECDF plot, RUG plot. And for all these 4, the wrapper is disk plot. So either I can use them one separately, individually, or I can plot all of them by using this disk plot and giving kind is equal to KD, HIST, ECDF, or RUG. For relationship plots, we have got scatter plot, line plot, reg plot, which gives me regression line, LM plot. This we had seen yesterday, that's why I'm not covering. Rel plot is the wrapper for this. The difference between these plots and this wrapper is that these plots are plotted at axis level. In wrapper, it acts at a figure level, that automatically it makes a figure and it does everything. That is the difference. Now we come to the 3rd category, which has got bar plot, count plot, box plot, violin plot, strip plot, swarm plot, and for them the wrapper is cat plot. This is the 3rd wrapper, 3rd and final wrapper. Okay, any question till now here? Anybody?
Sir, I have a question here.
Yeah, please.
So the way you have explained, there are individual plots and there is always a wrapper to control the figure at the figure level. So suppose I need more control, for more detailed control, can I do the same, have the same amount of detail control with the wrapper, or for detail like micro control, I need to use the individual plots, or the level of the same across the wrapper and the individual?
Yeah, so I have understood your question. So like I had covered during Matplotlib also, that if you want to have more control, then you have to use Matplotlib. Okay. And the second, if you are using Seaborn, then use the individual plots that give you more control. When you are using a wrapper, it might not give you so much of control, but you can do still those kind of things. You can move the legend, you can control the fixed size and all that. And I had also covered that in the same, when you build 2 axes, in one we change the legend using the Matplotlib, and another axis we change using SNS, move legend command. But if you want more control, then the Matplotlib you have to use. But the aesthetics of the Seaborn are much better than Matplotlib. We'll see that as we go through. Okay.
All
Okay.
right. So just a follow-up, quick follow-up question here. For instance, just an example as we move forward. Like
Yeah.
you showed that the confidence intervals by default when we do the line plot, right? Now instead
Yeah.
of confidence interval, say I want to show the SEM, the standard error of mean, as
Yeah.
the error. In
Yeah.
that case, which one would you suggest? Just something you might
So
already cover in going
yeah,
forward.
so in that case, when you go to the argument, you can see the full command. So there you can you can select different things also. Okay, so instead of CI, you can select different thing also.
So is that possible using SNS, as in Seaborn, the individual plots, or do I have to use Matplotlib for that?
Most of the things are possible in Seaborn, most of the things. But like I mentioned yesterday, at many places you will have to use Seaborn also and Matplotlib also, and we will see those examples as we move forward. Okay,
All right. All right.
where do we have to use the Matplotlib also? Okay. Now we come to the third category, and the wrapper for this is the cat plot. Let's see all these plots. So bar plot we have seen in Matplotlib. What does it do? It is a nickname. I will call it a compare averages plot, and it will answer that which category has got the higher average value. So for the individual, I'm plotting this SNS dot bar plot. I'm passing data. I'm passing X and Y, and I can also do, for example, here I have defined this X is equal to SNS dot bar plot. I'm passing data X and Y. I'm giving hue is class, and I'm passing error bar is none, because in this by default error bar comes. Okay, I will just write here. And then I'm using this SNS move legend. And yesterday we had covered that, for example, in Seaborn, if I want to have numbers on top of the bar, then I have to use this command. This is like a magic command which works in Seaborn. For container in x.containers, this x is the name of my this. I pass this x dot bar underscore label. So this is the matplotlib command. If I want to have the numbers, let's see how these both plots will look like. Okay, so see here, if I'm just plotting a bar plot giving data X and Y, so here is the survival rate. It is a probability of, so for the males, what was the probability? It was around 0.18. For females, the survivability rate was around 0.72. So it's a big valuable insight about your data. Now, when I do with the hue class, so I will come to know class wise also, and I'm this error bar is equal to none, and then I'm passing numbers also by this command, and I'm moving the legend using the SNS. So see here, individually now I have got the all the probabilities. So see here, for male first class, the probability of survival was 0.37, second class 0.16, third class 0.14. Whereas for females, for first class 0.97, almost all of them survived. Female second class 0.92, third 0.50. So this is the power of visualization. You know what kind of insights they can give you. That differences between the survivability rate as per the gender and as per the classes. Similarly, you can plot this. You can put here by the embark station. So you will come to know that which all places the passengers had embarked and what was their survivability probability. Okay. Now, if we want to do this using the wrapper, so the wrapper for this is the cat plot. Using wrapper. Okay, so I'm passing same data X, Y. I'm passing kind is equal to bar for bar chart. I'm passing hue, sex, error bar is equal to none. And again, I'm doing the same. I'm passing G, and for X is flat, again, I'm flattening. So when I do this for in a wrapper, I have to take one extra step. For that extra step, what I do, first I make this, so this wrapper happens at the scale of where it is happening. It is happening at the figure level. So this G I'm making, so this G is the figure. And now here I am G using, it is a figure. This is the axis. I'm flattening those axes, and then I'm selecting them one by one. And then in this X container, I'm passing the same magic command for the writing the numbers on top of that. Okay. So this is only for the gender wise. So the same numbers have come and it has come the class wise. Now the next plot is count plot, means how many, like in the categories, how many passengers belong to each group. I can see from the embark side also, I can see in the passenger class also how many passengers were there. So let's see, the basic plot is sns.count plot. The argument, you give the data and you give only X. Second, I can, with this, I can give the hue also. And then this magic command for container in X container, I can plot the numbers also on top of that. So let's see how it will look like. So in the first, only first class, second class passenger count has come. So you can come to know what are the counts approximately. And when you are passing hue and you have used that container in X.containers, then you get the actual numbers. That in the first class, there were 122 males and 94 females. In second class, these many males, these many females. So this is the power. Now you can use this in combination. For example, instead of class, you can use embark also. So we'll come to know how many males and females they had boarded from different ports. Now for the wrapper, so for a wrapper, I want to give the number. So what I'm doing, this is the figure. When I do sns.cat plot, so when I do the wrapper, it happens at a figure level. So I've given the name to that as G.
G is the figure, no?
It is happening, yes, it is a figure.
Okay.
Okay. So wrapper happens at figure level. Now in that figure, I'm selecting axis of that figure, G.axis, then I'm flattening them, and then I'm selecting them one by one. And then I'm using this same command for plotting. Okay. So here I've got this numbers now. Survival count by class and gender. So here I have selected class data tightening and hue is sex. So this is wrong. This is the count of passengers. Okay. Title is incorrect. I've corrected it. Okay. Now we come to next box plot. We have seen in Matplotlib. Only here in SNS, there is only one subtle difference is there. So in SNS, we use the same plot command, sns.boxplot. I pass the data. I pass X and Y. Now, depending on where you are giving this X and Y, your plot will come either horizontally or vertically. So here I have given X is equal to class and Y is equal to fair. Here I have inverted them to change the look of this. So see here, this is a vertical plot in the first class. This is an outlier fair wise. So we know this 500 fair which was there, it was in the first class. There are so many outliers in second also, in third also. And if I want to see horizontally, then I have just changed the X and Y and it has come in this. Now here I can also do, for example, in a wrapper, and I'm also passing hue also is equal to sex. So same thing will happen, but it will come now for male and female separately. So same wrapper we are using cat plot. Okay, now we come to violent plot. So violent plot, basically it gives us, the nickname is shape and spread, that in the same plot we can come to know about the full distribution across categories, that how is the distribution. For that, command for the basic plot is sns.violentplot. We give data X and Y, class and fair. Inner is quartile. It means this, the figure which it will plot, it will plot quartile wise. So let's see how does it look like. So see, for first, second and third, this is giving me the indication of the distribution, that there are so many outliers up to here. Okay. So this second violent plot gives me that information. Whereas in the third class, you can see there were many people who were close to the median or the mean place which is there. So that valent plot is used for this. Now here I can also give hue. So it will give, if I select hue is equal to sex, then it will give separately for male and female, looking similar for all. So there is not so much of difference. Now we come to wrapper. We come to give the same arguments, only we pass kind is equal to violent here. We are passing hue is equal to sex. Split is equal to false means they both will separate from each other, and I'm passing same inner is equal to quartile. Okay, so same plot has come using a wrapper. Now we come to strip plot. So strip plot basically plots the raw data dots. So if you have got less number of data and if you want to visualize it, this is recommended. So question basically it answers that where are the individual data points. So here, for example, I'm using SNS.strip plot, which is the basic plot. I'm passing data X and Y. Jitter is equal to true means that if some data points are closer to each other, they will be separated. And next plot, I am passing hue. So let's see how does it look like. Okay. So see here in the first, second, and third class, these are the data points which are looking like. And by jitter, I have given jitter is equal to true. Otherwise, if I don't give jitter is equal to true, then they will come in a straight line. Okay. By giving jitter is equal to true, they are separated. And here, when I'm giving hue, sex, male and female, so now it gives us the indication that, for example, it can give me an indication that in the first class, females and males, they were like equal distribution. But whereas in the second class, majority were males. In third, again, the majority was male. And second command is dodge. Dodge you can use with a strip plot. And basically the dodge also, what it will do, it will shift the point for each hue group to the left and right to create a space between them for better visibility. So let's see what happens. And then I will use the wrapper sns.catplot. Same data I'm passing, kind is equal to strip in this, and I'm also passing dodge is equal to true. Okay, the same plots.
If this data in the first class it is being shifted, how it is the data is managing the data points are having the fixed values in our Titanic data.
So I will just show you. If I make dodge is equal to false, what will happen?
Yeah. Dodge is equal to false.
It will come in a straight line. Okay. So they have come in straight line. It is not readable. So if you want to have readability, in the second, they have shifted to the left and right. So you can easily read that these are the males, these are the females in first class. Okay.
Okay. Data points are values are same, just they are separating on the first category and second.
Yes. So I didn't mention that data values are shifting.
Correct. Because data values are the fair only, right?
Yes. Okay. Now we come to swarm plot. Swarm plot, basically, these are the smart dots without any overlap. So whatever we were doing here, it will do the same thing here in the swarm. And can I see the all points without overlap? So you will get the similar kind of plot in the swarm also. So basic plot, we plot Seaborn dot swarm plot data X, Y, and this is the size of the dot. Default size is 5, and when your data size is more, then it will conflict. So you have to control that with your size. So here I'm using size is equal to 2. And in the second plot, I'm also using hue. So it takes some time because it is plotting all the plots. So here, see here, it is giving warning also that we have to decrease the size because the Titanic data set is quite big. Okay, so here, see, I have not given any other argument. So that's why everything has come here in the same. So these are the data points, number of data points which are there. And fair distribution without overlap, it is hue, male and female. So this is the distribution. And for the wrapper, the same cat plot is used, only we pass kind is equal to swarm. That is the only change. And we also can pass dodge is equal to true so that they are separated. And let's see how it will look like. It will take some time, we'll throw some warning. So see, by doing the dodge is equal to true, they both have got separated and gender wise. So till now, we have covered three types of categories: distribution, relational, and the third type. And we have covered all the three wrappers. So these are the three main wrappers in Seaborn. First wrapper, can somebody tell me what is the name?
This plot.
Yeah, second?
Plot.
Rel plot.
L plot.
Rel plot, and third plot?
Cat plot.
Cat plot. Okay, so remember, just by the name itself, you can immediately remember what it is covering. So this plot is a distribution plot. In the distributions, we have got histogram, we have got KD, we have got ECDF, we have got rugs. So by passing kind is equal to that, I can see the distribution. When I come to relational, I have got a scatter and I have got line. So I can pass kind is equal to scatter, kind is equal to line to have the relation plots. The maximum number of plots are in the category plots, where we have got bar plots, we have got swarm plot, violent plot, okay, count plot. So by passing that kind, we can get those plots. So with this, I have covered most basic type of plots and along with their wrapper. Now we come to heat map, and we will realize, and I will demonstrate to you that building a heat map with Seaborn is much easier than Matplotlib. And that's why in all your machine learning projects, you will be using Seaborn only to build the heat map. And what do we do that? First, we find the correlation by selecting the D types number, so they are numerical, and using the command core. So this is, we have found the correlation, and we just pass seaborn.heatmap. We pass this core. N0 is equal to true, though, so that your numbers, they come inside, and we pass a color map, what kind of colors we need. So with this, just two commands, you can prepare your heat map. If somebody wants to try out in Matplotlib, it takes a lot of efforts. You have to do a lot of mathematics.
This will work for only numerical data only?
Correlation in statistics, it is between what?
Numerical data only. No?
Yes.
Yeah.
Okay.
Okay.
Yeah. Okay. So see, in the Seaborn, just by two commands, you are just finding core for the numerical data, and just by sns.heatmap passing this data, annotation is equal to true, just to see the numbers. So this is so easy. It does not have any wrapper, so heat map is used. Okay, heat map is standalone. Now, second is a pair plot. Pair plot is nickname is EDA in one line, and it is used basically when you load the data and when you fill the data. After filling the data, you do this pair plot. So in this one line, you will come to know all the relations. So it gives you a broad overview that how my data is there, what all columns are there, what kind of relations are there. And then we go to do analysis column by column, one by one. So pair plot is used in first place. And basically it answers the question that how all my features, they interact pair-wise. So see, I'm giving sns.pair plot. I'm giving the entire data set, and I'm passing hue is equal to surveyed. And it will give relation or the visualization of all my columns one by one. It takes some time because it involves a lot of computation. But this is a standard step which we do after loading. So here you can see passenger class. It is giving indications all. Okay, so there are three type of passenger classes are there. Their survival rates are also there. We come to age distribution has come. So all kind of relations you can find here. Okay, so like for heat map, for this also there is not a wrapper. Okay, so with this, I have covered all, I think, majority of the seaborne visualization methods. Any question till now? Anyone?
So the heat map in Seaborn is easy because in Matplot we have to filter the columns having only
Yes,
numerical type and
yes,
then
yes, you're right. So, but I can see in Seaborn also everything is happening, but it is a wrapper. Like Seaborn is also a library built on Matplotlib. So everything it is doing, but it is doing in the background.
yes,
Okay.
sir.
Excuse me, sir. Could you just open the heat map once?
Yeah,
I have a doubt there.
yeah, yes.
So here in the heat map, the color bar shows like it's normalized to one, right? It goes from 0 to 1. Suppose, I mean, not zero, negative as well as 1 up to 1.
Minus
Suppose
one
I
to
want
one.
to yeah, so -1 to 1. So suppose I want to change the scale of the color map, like I want to change the numbers, like I want to show absolute numbers or something like that. In that case, will it depend purely on the data, or can I actually change the scale of the color map? I mean, can I tweak the color bar itself?
No, no.
Do I?
See your correlation, the quantity, the correlation when you define, it is always between minus one to one.
Oh, I see. But I see. Okay, here this is correlation. Suppose I don't want to plot correlation. I want to plot some other quantity, other mathematical statistic. In that case, can I still use heat map?
No, no. For that, heat map is not there. Yeah.
So
Okay. Just hold on. The core has given you a data frame. Okay, and that data frame now you are plotting with heat map. So in heat map, if you pass any data frame, it will give you the visualization.
so it depends on the data, my data itself. The data
Yes,
frame
yes,
has correlations. That's why it's between -1 and 1.
yes, yes,
If the
yes,
data is a correlation data, something else, then it will plot accordingly.
yes,
The
yes,
statistic.
yes,
Oh,
yes, yes. Okay, so here I'm passing this data and I'm passing this annotation is equal to true and it is giving me this.
all right, all right. Thank you, sir.
Okay, yeah. Okay, so any other question?
So now when we are using wrapper class, there is only one axis or there can be more than one.
The wrapper, what you can do, see, you can build the axis using, I will just give you this task. We will take a just 3 to 4 minutes of break. You try doing one thing. You build a figure using Matplotlib, and in those axes, okay, use a wrapper. Let's see what happens. Okay, Prashant.
Okay, okay, sir.
Okay, yeah. Okay, so I think we have covered 1 hour. We will just take around 4 to 5 minutes of break so that we start a new thing. Okay. So any question about Seaborn distribution, the Seaborn gives us a power. In Matplotlibs, we can visualize only between two variables. Seaborn gives us a power that we can see relation up to 4 variables also. Like we saw in the relational plots, that by passing hue also and by passing style also, I could see the relation between four different columns. So that is the power of Seaborn. And in machine learning, I tell you, visualization is a very powerful tool. It builds intuitions. Like immediately we came to know that, females in first class, they had a probability of survival 0.97. It's a very important statistics, and we just derived it by just visualization only. Okay. So with this, we'll just take a short break and we'll start maybe after 3 to 4 minutes. Okay.
Okay. Okay.
Okay, hi, I'm back. Okay, so before we start, any other general question or any doubt? So before we again dive into this fascinating world of visualization.
Sir, so
Yes,
for
yes.
the access question which I asked in Seaborn,
Yeah,
you
yeah,
asked me to create access in Matplotlib and plot each axis using Seaborn.
yeah.
But in Seaborn wrapper, the graph is made for a figure, not for axis.
Try it, try it. I just told you, try it.
Okay.
Hello. Hello.
Yes, Vikas.
Lalit sir, actually I wanted, it was a request, a small request. Could you please share more resources like books and other stuff where about Matplotlib and Seaborn so that we can practice further. And
Okay,
plus, yesterday's video was some different one.
okay.
So,
Yeah. So I'll answer both the queries. So number one is that the best resource for Matplotlib and Seaborn are their documents. And second is that as
okay.
you keep on practicing, as you will handle the machine learning projects, your proficiency will increase many folds. Unfortunately, to say that C-bound document which is there, it is not structured in a good way. Like
Yeah,
what I covered, that these are the plots and then this is a wrapper. This kind of material you will not find anywhere, and that's why
yeah,
most
from
of the
basics, it is
yeah,
not from basics. It is just what if you know everything about it, and
yeah,
if you are forgetting something, you can refer to it. But not like
yeah,
if
yeah,
you want to build it from scratch,
yes,
you won't be able to do
yeah.
that using documentation.
Yeah, so I'll recommend to everyone that this collab will be a good, rich resource. Okay, because it has gradually built from the basics, then it has covered everyone one by one. Okay.
Mhm.
Third thing is about your recording. So today in the morning, so there was a fiasco from Google side. I had, okay,
Oh,
they had sent me that file and I thought it is the same one. And today in the morning in the G space, I have shared. Okay, so you can go there and you can have that. Okay.
yes, sir. I mean, today's recording also, if you could just arrange it uh, in today itself only, so that
Yes, yes, yes,
we
yes.
can use
I
it
will
for
do that.
exam also.
Yeah, I will do that. And what I will do, that I will give you one full complete day to assimilate everything. I will release the assessment tomorrow, somewhere in evening time, and I will give you
Okay.
time till day after tomorrow, 9 p.m. Okay,
Yeah,
right?
that would be great, sir.
Yeah,
That would be really great.
and
Thank you.
but I will share you my consistency. Unlike NumPy and Pandas, here in visualization, I cannot give you visualization questions types because they cannot be checked, they
Fair.
cannot be tested.
Fair.
Okay, so this assessment will not be so heavier like NumPy and Pandas, which gave you more exposure. Here for this workshop, this collab which is there, it is much, much more resourceful, and you will learn a lot from this collab.
Yes, that is correct
Give,
actually.
give
Yeah.
some more time, sir, for this emission because other workshops are also they're coinciding the same day. They are
Pra-
also shining.
Prashad ji, unfortunately, the assessment, like I covered, assessment is much, much easier than NumPy and Pandas. And
Okay.
I'm giving you one full complete day. You have got till tomorrow. And you can complete the assessment using this collab. I can tell you honestly.
Okay.
Okay. And keep on learning. And like I had promised yesterday, I will share a resource also in G Space. It
Yeah,
is a
yeah.
YouTube and GitHub repo also. I made it long back, and it is a very, very rich resource. I tell you, you will not find that kind of resource anywhere. Okay,
Fine, sir. Fine,
yeah,
sir. Thank you.
okay,
Yes, so that would be great. Sharing the GitHub repo would be really
yeah,
great addition
yeah,
because okay, fine.
okay, okay. Let's start now. Okay, thank you. Okay, so we had seen pair plot.
So can I ask
Now,
one question?
yes, please. What's your good name?
Uh,
Siddhant. Yeah.
sir, my question is that whether means this assessment tomorrow you will be giving, that will be the exam, or the exam will be separate means?
No, so there is no separate exam. This assessment itself, it is your exam. Okay.
Okay, sir. Thank you,
You
sir.
have you have to score 60% and more to get the certificate. Okay, only that.
Yes, sir.
Okay.
Okay, sir.
Okay.
Thank you, sir.
So after seeing all these plots, so basically the final takeaway is basically that Seaborn is not about memorizing the functions. It is about asking the right question and picking the right plot family. So we have seen three families, and then three families were distribution family, relational family, and the categorical family. And now I have to ask myself, what do I want? What is my column? What kind of relation I want to see? Am I checking some distribution? And then either using the individual plot or the wrapper, I can do that. And then the two other plots which are there, for example, the heat map and the pair plot, they are for their own purpose, which we know. Okay. Now I will cover certain other things also, like the color palettes. Color palettes are basically to build the aesthetics. So there are three types of color palettes are there in Seaborn. One is sequential, which is light to dark. Example, temperature, we can use for temperature, age. For that, the palettes recommended are blues, or palette is equal to red. So it will start from light red, then slightly darker, then the darkest. So that will is used for the sequential data, numerical data. And second is for diverging. For example, if I want to see between profit and loss, then I use the palette like cool warm or the palette like VLAG. So it will distinctly, divide my data when I'm going from one end to another end. Third is qualitative, like the distinct colors for distinct groups. For like for male and female, I want different colors. So then the palette recommended or commonly used in Seaborn is palette is equal to SAT2 or palette is equal to HUSL. So the tip is basically from my side is that if you are exploring data and want answers fast, use Seaborn. And this question was from Deka, and this is the answer, that if you are building a specific report and need pixel perfect control, use Matplotlib. But for most of your machine learning projects, your Seaborn and Matplotlib, they are used majorly Seaborn and in some part, some features of Matplotlib. Now to again demonstrate, for example, the difference between Matplotlib and Seaborn, again, I will use the data set which we had used yesterday, tips. So we will load that data set from Seaborn library, and let's see how does it look like. So I will just see tips.head. So this has got total bill, it has got tip, then categorical column sex, smoker, day, time. Time is again categorical dinner, lunch, and size of the family. So it is a toy data set. Now we will see that if we want to build some kind of plots like a bar plot, how, what extra steps we have to do in the Matplotlib and how the things become easy in Seaborn. So for example, if I want to use a Matplotlib and I want to plot the aggregated data, that is day means, I want to know that how was the average total bill was there and the tips. So first I have to do the group by data by the day and the total bill. I have to calculate the mean, and then I will use this index of this day means and the values like we had seen day for yesterday when we are plotting for Matplotlib. And then we make a, for bar chart, we define dot bar. We are passing this. We are passing the data, days, values. From here we have taken that, and color we are passing, and we are passing title and the Y label. And for adding the labels on top of that, again we will put bar label and giving the dot 2 to define the decimal value. For the scatter value also, we will put the tips total bill. Whereas in the Seaborn, the life becomes much more easy. So I will not explain everything we have covered. Just I want to cover the aesthetics and how the things are much more easier. So see, this is the Matplotlib. It has given me average bill by day, bill versus tip, but there is no information gender wise. I cannot do that. But whereas if I do in a Seaborn average bill has come very easily displayed on top, and here I can visualize gender wise also. So this is the power of Seaborn. Okay, I'll give you another example also. So like in the Matplotlib, we had to manually group by and calculate the mean before we could even start plotting. Whereas in Seaborn, we just pass the data and y is equal to total bill. Everything is done internally. Okay, similarly for multivariate data, for a scatter plot, when we plotted with Matplotlib, it was a gray and simple. In the Seaborn, by giving the hue is equal to sex, immediately we come to know. Okay, the second, okay, this I will not explain. You can go through the collab. They are just basically to demonstrate the power of Seaborn over the Matplotlib. Like for the Matplotlib also, I can have this kind of data, male and female, but I will have to write a lot of code for that. I will have to change, for example, P class sex, again group by, and then take those values, writing so many codes. Whereas in Seaborn, it is done by a single command. This is a command and it does everything. So that's the power of Seaborn. Third is the heat map. Like for the heat map, how do we do in the Matplotlib? You have to do the loops one by one. So this is the loop for the Matplotlib, and I have not seen anyone till now. I have seen many machine learning projects, anybody using this. Whereas in the Seaborn, this is just one line command after finding the core. Okay, and so for Matplotlib, you see the number of codes lines which you have written here, and here just one line command in the Seaborn. So this is the power of the Seaborn. Third is, for example, if we want to show the distribution of total bill, but creating a separate graph for lunch and dinner. So in the Matplotlib, we will have to filter the data frame manually. We will have to select data frame by lunch and dinner, then plot it on the same axis to see. Whereas in the Seaborn, I just pass call is equal to time, and immediately it will make two facets. So this yesterday we had seen this, that if we pass call, so one command just total bill, call is equal to time. So time was that dinner and lunch. So it makes in one command. Now, the secret sauce, which I have been mentioning from day one, and that in the Python visualization, you have to understand both Matplotlib and Seaborn also. Because many things Seaborn does efficiently, it does the complex maths internally and draws the main shapes. Whereas the Matplotlib job is to add the decorations, which is not there in the Seaborn. For example, you want to, draw the lines, add text, you want to change the limits like Umapati ji had asked on day one. You want to change the rotation of your X labels and all that. So that everything is done by the Matplotlib. That's why with Seaborn, if you want to decorate your chart, then we use Matplotlib. Now we will see some 10 real world examples that how do we combine Seaborn with Matplotlib. So for example, we have plotted some sales using Seaborn, and we want to show the target. So there is a target line we want to draw. So we use Seaborn just to SNS bar plot. I'm plotting the basic bar plot by using Seaborn, passing the data types, X is day, Y is total bill. Confidence interval is equal to none I'm passing. I'll request everyone to mute their mic, please. Yeah. Now here, for example, at y is equal to 20, I want to draw a line. So here, this is the command from Matplotlib, plt.x hline. Hline means horizontal line. Y is equal to 20, where I want this line at y is equal to 20. Color is red, line style is dash dash, line width is 2, label is target revenue. So see, by combining both power, I get a decent look plot where I have got revenue and target also. I have defined that target was 20. So on these 2 days, I could not meet the target, but on these 2 days, I have met the target. So that's how we combined both Seaborn and Matplotlib. Let's see second example.
Sir, sorry
Yes.
to disturb, sir. In this graph, can we give one more target of the previous week? I'm just
Okay.
asking. Please don't
Okay.
mistake.
Okay.
Just
Okay.
the
Umapati ji.
same
So
line.
yeah. So we will find out that, and maybe we
Yes,
will.
sir.
Yeah, we'll find out that.
That will be
That
nice. Yes, sir.
I have understood your question that we want to draw two lines, for example, minimum target, maximum target.
No, sir. Previous week. If we include the previous week, we can compare with this week achievement. That will be interesting, sir.
Yeah, so what we can do, for example, in this SNS.bar plot, the Seaborn gives us the power of using hue. So if we had okay, that weekly data, for example, then by using hue, we can display that.
Yes, sir.
Okay.
Yes, sir.
Okay. Okay. For example, if I see, I'll just see the tip. What is the data in tip? In tip, whether that is there or not. So let's see. I will just tips.column. I will just see, and will it work or not? Okay, so it has got a column called sex, and let's see. Let's pass hue is equal to sex. Okay, so it can give us this column wise, male and female wise. It can give us. Okay, so we see, for example, for females, your total bill is always below the total your target. Only in one case on Sunday it is touching. But what you are asking that we want to compare weekly data, then what I have to do, I have to prepare that weekly data column by coding, and then I will add that column here as a hue, and then it will be. Okay.
Yes, sir. Yes, sir.
Okay. The second example is, for example, we want to highlight an outlier. We want to annotate that. So we know that in SNS, we can plot a scatter plot. So we are passing data types. X is total bill and Y is tip. So in X total bill is coming, Y is tip is coming. Now I want to annotate that there is an outlier. For example, there is a big tipper somewhere. So for this, I use Matplotlib, and the command is plot.annotate. I'm giving the name of that big tipper. Where do I want X, Y is equal to 50, 10? That X is 50, Y is 10, tip is 10. XY text will come at this position, 30 and 9. Arrow props is dict face color is equal to black, giving color, and shrink I'm giving. So by doing this, I can annotate on a this. So this is a where I'm using a Matplotlib to annotate, and I'm using a Seaborn graph. And here I can also give, for example, hue also I can give. I will immediately come to know who was this.
So by the annotate method, we are creating this arrow.
Yes, arrow at a definite place.
Okay. Position and the thickness are like that, right?
Yes, yes. Okay. So by giving the hue, immediately I come to know that he was a male. Okay. So this is the power. Okay.
So the pixel coordinates you're giving, right? For the location,
Yes.
position.
Yes. 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 So this is 50 and 10. I know here is the position. So this is the position. I'm then passing position for the annotation 30 and 9. It will start from here. And this is for the arrow props. Okay. Okay.
First we saw the data point is over there, and then
Yes.
the
Yes.
arrow.
Yes. See, many times for your charts and for your reports, you want to add this. So by doing Seaborn, you cannot do that. But like in your PPT, you want to add this. So Matplotlib gives you a power to add here. Okay.
And shrink,
Okay.
what shrink is doing here in the arrow? In the arrow, shrink.
Shrink. I'm not aware, Prasad ji.
Okay.
Really.
Okay, fine. Okay. Okay, fine. We will search it. Okay.
Yeah. It is just arrow props which are there. I have passed a combination of the face color, and this is standard
Okay.
command.
Okay. We will
Yeah,
explore this. Okay.
let's change it. Okay. Let's change it to 0.5.
Yeah.
Maybe
Yeah.
maybe something will happen. Okay, shrink. This is the shrink. So it has reduced, size has
Okay,
reduced.
okay. Length. Okay. Fine. Thank you.
Okay. Now, in some cases, we might have to rotate the axis labels, that your axis labels, they are conflicting, they are not becoming readable. So, for example, we are making Seaborn count plot, and for rotating the labels, what we have to do, we have to use this plt.xticks. Xticks is for the x labels, yticks is for the y labels. We are giving rotation is equal to 45 and HA direction is right. So this is a horizontal alignment, HA. So it will rotate 45 degree aligned to the horizontal. So by this we can rotate our labels. Okay, so your labels have rotated. By similarly, if you want to rotate your Y labels, you can do the rotated labels also, Y also. Now, this is a question which Umapati ji had asked me on the day one, that there is a scenario that we are plotting, but we want to zoom a certain portion of that. So we will plot with the help of Seaborn. I'm plotting a box plot where I'm passing data tips and X is total bill. Now, I want to limit, for example, X limit from 0 to 30 only. So here I pass this command plt.xlim. So this will limit my X labels. It will display only from 0 to 30. It means I have zoomed in to that portion. So instead of seeing the entire figure, I'm just limiting and seeing the zoomed in space.
Yes, sir. Got it, sir. Thank you.
Okay. Yeah. So similarly, in other plots, you can do the limit by ylim also. Somewhere you want to limit your y axis, you can use this command. Okay. Now customizing the legend position, this we have enough seen. So this I will not cover here. This BB box to anchor, and Seaborn has also got its own method, move legend. Now, for example, if you want to have dual axis, y axis on the left also, y axis on the right also. So how to do that? So what do we do? First we make figure and axis. So I have made one figure and one axis called x1. Now on this x1, I am plotting a Seaborn bar plot. I'm passing data tips, x is day, y total bill, x is equal to x1, color and error bar is equal to none. And I'm setting the y label. So I have done that. Now to have a twin axis, this is the command which I do. I make a twin of x1 by passing x2 is equal to x1 dot twin x. So this will create a twin of my x1. Remember, x1 was created and now x2 I have created as a twin. And on this x2, I will plot a line plot using Seaborn, giving this. But here I will use x is equal to x2. So here you see, you will get a 2-axis plot. So on the first axis left, you are having a total bill and it is giving you the bar values. And if you want to know the numbers, you can add the numbers also. And on the right axis, I'm having a line plot. So on Thursday was 2.5. Okay, this is the average tip. On Friday, it was less than somewhere around 1. On Saturday, it increased to around 10, more than 10. And on Sunday, it was around more than 20. So this is how we can plot a twin axis plot using the Seaborn.
Red
Now-
line is showing the tips and it is showing the bill, right?
Average tip, right?
Red line is showing the average tip.
Yes. And
Okay,
this is the bar chart.
Okay, fine.
So for the bar, we have to refer to the left axis and line the right axis.
Yes.
But-
See, when I have defined, so I made first this x1. I plotted the bar chart on x1. So by default, it has come on the here on the left. And then I made a twin of x1 by this x2 is equal to x1 dot twin. And on this x2, I plotted a line plot. Okay.
Okay, so we have to, while reading, you should know this and
Yes.
refer to the correct axis.
Yes. Okay.
And axis you
But
meant like a plate, right? So, but there
Yes.
is only one plate.
So
There is,
on one plate, I have plotted two. So that I had shown on the Matplotlib also, if you remember yesterday, that on the same axis, I had plotted sine plot also, cos plot also.
yes, sir.
You remember? Okay.
Yes, sir. Similar to that.
Yeah. So it is like the analogy, on the same plate you are keeping different type of foods. Okay.
for
Now,
such type of first type of plotting, x-axis should be common for both. Then only it is possible, right?
yes, yes.
Okay. The data should be
Okay. Yeah.
commensurate with that.
Yeah.
Hmm.
Now, in some charts or for some reports, for example, you want to add a text box. Well, you have made a chart, but you want to add a text box. So for that, again, you will have to use Matplotlib. So I have plotted, for example, a Seaborn his plot with the tips and total bill, which will give me the counts of that. And I want to add for example, a watermark called confidential. Then what I do, this is the command to add a text on a chart or on a plot, plt.text. 0.5, 0.5 means 0.5 top, 0.5 width. It means coming in center. This is the figure I want to see, confidential I want to plot. This is the font size, color, alpha is the depth of that, horizontal alignment is center, vertical alignment is center, and transform, this is the command, a magic command which you have to pass here. I don't know the meaning of this. I have not explored the meaning of this, but when we do this, it is a standard which we pass. And if we do, we can get this text at a position where we want. Okay, so this is how, or if you want to add here, that also you can do by manipulating the arguments here. Now, for example, you want to format currency on axis. So instead of 10, 20, 30, you want to have dollar with that. So for that, you have to use something called string method formatter, which is known as str method formatter, which we import from matplotlib.ticker. So what do? We make a Seaborn bar plot. And then here, this plt.gca, which is there, this is the function. From here, we select y-axis, and here we use this command, set major formatter, use this string method formatter, and we pass this $x hash 0.0f, means no decimal, and I'm adding dollar before this. So this will add dollar to your y-axis. Similarly, you can add similar kind of thing, whatever you want to add in your x-axis also. So this is for adding the strings on your axis. Now, the second last one is, for example, you want to shade a region. You want to highlight a range where you have got something to show. For example, you want to highlight the lunch rush area on a time graph. Okay, so for this, I'm plotting a scatter plot where I'm total bill and y tip. So this is my scatter plot here. But here, I want to highlight the bills which are between $10 and $20. So for that, I use matplotlib command called plt.xvspan. Vspan means vertical span, from where to where, 10 to 20. Color is yellow, alpha is the depth, and I'm giving the label to it. So it will immediately, from 10 to 20, it will highlight. Okay, and label has come, that is, this is the standard range. Last one is, you want to have picture in picture. Many charts, many PPTs, you might have to put that. So we are showing the full data set. However, for a certain portion, we want to zoom in. So again, we make fig-x standard command. We plot a Seaborn scatter plot for the total bills and the tips, which will give me the relation. Now here, to do the picture in picture, I will use Matplotlib. So what do? We first define the area where we want. So we have to pass this left, bottom, width, height. And these are the places 0.2, 0.6, 0.25, 0.25. So these are the left to bottom, how much, width and height. And I'm using this fig dot add axis. So in this figure which is there, I'm adding one more axis. So with this parameters, one more axis will be created in this figure. And plotting the same data now, I will plot in this new axis which I have defined as x underscore inset. Okay, so here I pass again scatter plot, total will weighted, but x is equal to x underscore inset, color is equal to red. And I can, for this axis, I'm limiting my x axis, x limb from 40 to 55, y limb from 4 to 10 to basically zoom into that area where I want to show that spatial area. For example, these are the big spanders. Okay. So here, picture in picture, from here, I have been able to show this things which are there, 1, 2, 3. So these plots have come from here, this one. I wanted to highlight them and I have been able to do so. With this, friends, I have finished this workshop. I have added certain extra which I will share in the collab, but most of those things I have discussed already. I will not go over them again. So now if there is any question or any general doubt or any other thing we can discuss, I'm available. Yeah, Prashant, could you plot that?
No, sir. Now I'll do it. But I think we can do it using AX.
Yeah. You try that and you share in the G space. Okay. And regarding your NumPy and that Pandas workshop, my team is checking about your payment. So if we find your payment has been made, then the certificate will be issued. There should not be any problem.
Okay, sir. Thank you.
Yeah. Any other question, any other doubt, or if I ask you, how was it? How was the delivery? How was the content?
Sir, it was excellent,
So
sir.
the content and delivery is very good.
Enjoyed it.
Thank you. Thank you so much.
It was very exhaustive and
Yeah.
thoughtfully.
Like sir, you
Carved
have
out.
covered Seaborn and Matplotlib
Yeah.
by contrasting them also. That is the important thing which we got.
So I'll share with you. You all of you, you are the you are in data science field and machine learning field. You cannot build a machine learning model without visualization. The visualization, when you do EDA is nothing but it is visualization. Visualization is the first step which gives you the intuition. After that, then we use the statistical methods. Okay. Thank you, Abhishek. Thank you.
Sir, just
Real life
one
examples means where they will be used. That was with that you thought that was more inside.
Yeah, so Siddhant, that's why Malik, today I covered everything from real world. I use the Titanic data set and then tips. Okay. See, in the machine learning problems, you will either have a classification problem where your target label is a categorical data. And in your feature columns, you will have either numerical data or you will have categorical data. If I know, first of all, how to analyze my numerical data as a lone sum, then I know what all plots are there which I can use. The second is that I want to know the relation between this column and the target. Then I know. So either it is I have to analyze a numerical data column, I have to analyze a categorical data column, and then I have to correlate them, either numerical versus numerical, or numerical versus categorical, or categorical versus categorical. For all these three scenarios, if I know which plot to use, then I'm done. And once you do, you keep that, one of your master, whatever you do, keep it in your repository so that you don't have to invent, again and again. You can go back to that, what you did, and you can duplicate in your next project. That's how the things are done in the real world. Okay.
Sir, just on the lighter side, but
Yeah.
including the subject also, uh, I was telling yesterday on the G Space that how I wonder how Seaborn and Titanic came together. Sir, you yourself, you have been serving the nation airborne. So I just wanted to ask on the lighter side, how it was like visualizing from above in a three-dimensional coordinates, like you are teaching now us the graphs. So I just want a few seconds from yourself
Yeah.
about that. And every time you say plot, I see I hidden, silent, pilot,
Yeah.
from the word pilot. Thank you, sir, for serving the
Yeah.
nation.
Yeah, thank you, Umapatiji, for your kind words. So, see, we live in a three-dimensional world, but all your data or what we analyze, for example, we analyze satellite imagery or we analyze any data. So, it is always in two dimensions, but the third dimension is always annotated or it is enhanced by using different colors. Like when you see the SAR images and all that. So, that is
Certainly.
the power of visualization. It gives you the.
Satellite data is now in 3 dimensions now available.
So I mentioned the same thing, Prashad ji, if you heard me
Yeah.
correctly.
Yeah.
It is on a two-dimension thing, but by having different colors, it gives us the 3D meaning to have the insights
Yeah.
from that.
Yeah. Yeah.
Okay. Thank you. If there is no question, can we log off?
Sir,
Or
thank
we
you
can.
very much, sir.
Yeah, it's a very nice
Yes, sir.
session,
Thank you,
sir.
sir.
Very good collection. Good collection, sir. Good collection and compilation of that.
Excuse me, sir.
Yeah, Prashant.
So in wrapper class, can we also move the legend? Like move legend was
Yes.
part of individual or
Yes,
wrapper?
yes. In a wrapper also you can move
Okay.
that. Okay. By using that SNS dot move underscore legend. Okay. Okay, Vikas. So assignment will be released tomorrow, maybe around 6 p.m. and you will have time day after tomorrow, 9 p.m. to submit that. Please submit your assessments, then only the certificate will be issued. Okay.
Hello, sir.
Yeah, Vishek.
Actually, there is in the workshops portal there is another Power BI workshop, I guess,
Yeah.
but the date isn't mentioned. So if I register, sir, when it will happen? That I was.
Abhishek, really, I don't have information about that.
Okay,
Maybe
sir.
you
Okay.
can check that email. I think that announcement had come. It has got everything, including the instructor name, timing, date, everything is there.
Yes, sir. Yes.
Okay. Okay. Thank you. Have a very nice day and thanks for joining. Thank you. Happy learning. Keep shining. Bye bye.
Thank you.
Thank you, sir. Thank you.